Welcome to AI Podcast. I'm Alex, and today we're digging into a fresh EMNLP findings paper called LRPlan.
And I'm Maya. Give me the elevator pitch. What's the one thing people should remember?
LRPlan pairs two different kinds of AI models into a simple planner and refiner team. The planner drafts a plan, the reasoning partner tightens it up, and both are guided by a tiny playbook learned from just a handful of labeled examples. The result is more constraint-aware plans at lower cost than many popular multi-agent setups.
Planner and refiner sounds like writer and editor. Is that the right mental model?
Exactly. Think of the planner as the journalist getting the story down, and the refiner as the copy editor who knows the house style, the rules, and the common mistakes.
Nice. Who's behind this work?
The lead names to keep in mind are Karthikeyan and Mausam from IIT Delhi, with collaborators. It appears in findings of EMNLP 2025.
All right. Set the stage for the problem. What kind of planning are we talking about?
Natural language planning, where you have to satisfy both explicit rules and implicit common sense. Explicit constraints are the hard requirements like arrive before 10 or book at least 3 nights. Implicit constraints are the unwritten ones, like not scheduling dinner during the flight or not double booking a person.
So, why don't standard LLM agents already handle this?
LLMs are great at broad reasoning, but they often drift on strict rules in long plans. Classical planners handle rules well, but they demand a lot of handcrafted domain models. And many multi-agent systems debate or iterate, but they tend not to learn reusable domain heuristics from experience.
Heuristics, as in the rule of thumb wisdom that an expert planner would use.
Right. LRPlan's idea is to learn that wisdom up front from a few training examples, then reuse it at test time without needing a validator to hold your hand.
Wait, what's the validator part?
During training only, they check whether a plan passes or fails. They use that pass or fail signal to help extract useful patterns, rules, and common fixes. At test time, you don't rely on a validator. The two agents and their learned playbook are enough.
So how do they actually build that playbook?
They generate reasoning traces on a small number of examples. Then they run 3 lightweight meta processes over those traces. One pulls out recurring solution patterns, another distills concrete if, this, then, that style rules, and a third catalogs common mistakes with suggested fixes. Those become domain prompts that guide the planner and the refiner.
Sounds like teaching the team your house rules before opening night.
Exactly. Then at inference, the planner drafts a plan using those patterns and rules, and the reasoning partner refines it, leaning on the catalog of common mistakes and fixes.
Where did they test this?
2 places. First, a travel planning benchmark where you're stitching together flights, stays, and activities under real-world constraints. Second, a static version of Time Arena with household and lab tasks where every possible action and duration is known ahead of time.
And they compared against what? The usual suspects?
Yes, direct prompting and chain of thought, plus popular agent frameworks like multi-agent debate, auto-build, and XPL. They also looked at cost and the number of API calls, not just accuracy.
Good, because in practice, the bill matters. So, did LRPlan actually win by a meaningful margin?
It did. On travel planning, it achieved higher final pass rates while using fewer calls and noticeably less cost than those baselines. On the Time Arena setup, it completed more tasks end-to-end and committed fewer dependency violations, again with leaner budgets.
Why does the two-model combo help?
The planner leans into flexible language reasoning, which often captures common sense well, and the reasoning partner is stronger at keeping strict, explicit constraints in line. The learned playbook glues them together so they pull in the same direction.
Okay, practical question. How many examples does someone need to create that playbook?
Just a handful per domain, on the order of single digits. That's part of the appeal. You can get useful domain heuristics without a big data collection effort.
And you said no validator at test time. Does that ever bite them?
It can, and that's why the refiner and the self-correction notes matter. But the core claim is that the learned rules and patterns cover enough ground to keep the system on track without continuous external checking.
Let's talk about the ablations, because that's where the rubber meets the road. Which pieces really mattered?
Removing the refiner hurts. Dropping the pattern recognizer or The rule extractor also reduces performance. The study shows the full trio of learned guidance plus the two-agent workflow is what delivers the gains.
What about model choices? Is this tied to one vendor?
No, and that's a strength. They tested across two different model families to show the approach carries over. So you can think of LRPlan as an orchestration recipe rather than a single model trick.
Got it. Any catches we should keep in mind?
A few. First, with so few training examples, the particular examples you pick may matter. Selection bias is a real possibility. Second, reproducibility can be tricky because APIs change and not all models expose the same kind of reasoning traces. Third, on the travel benchmark, they evaluate on a validation split rather than a public test server, so cross-paper comparisons should be taken carefully.
That makes sense. Scope is another one, right?
Yes, the domains are travel and everyday tasks. That's a good start, but logistics, healthcare workflows, or enterprise processes are still open ground. They also talk about multilingual potential, but don't evaluate it here.
If I'm a practitioner, when would I reach for LRPlan instead of a bigger single model or a fancier debate system?
When your tasks mix hard rules and soft common sense, and when you can afford a brief setup where you label a tiny set of examples. If your budget is tight, the lower call count and cost will appeal. If you already have a rock-solid validator you can run at inference, other setups might still make sense. But LRPlan is compelling when you want consistency without a runtime referee.
Give me a concrete travel example. Walk me through how the team would fix something.
The planner might propose a 2-night stay, but the destination has a 3-night minimum. The refiner recognizes that minimum night rule from the learned playbook, bumps the stay to 3 nights, and then ripples the change through the schedule so activities don't overlap. It's like a careful project manager doing a sanity pass.
And on the household tasks side?
Imagine a lab task where a chemical needs to settle before you pour it. The planner lines up the steps, the refiner checks the dependency rule, spots that the waiting period was too short, and adjusts the timing so you don't violate the protocol.
That's helpful. What about the cost story? Why fewer calls?
Many agent systems iterate or argue across multiple turns. LRPlan keeps it to a clean 2-step pass. The knowledge is front-loaded into the prompts via the learned heuristics, so you don't need long back and forths.
If you were extending this work, what would you try next?
I'd tighten the rule extraction with a quick symbolic sanity check so only the best rules make it in. I'd also test on more complex, reactive settings where the world changes mid-plan and explore multilingual planning to see how well those heuristics travel across languages.
Maybe also standardize the cost comparison, right? Sometimes pricing differences can muddy the waters.
Exactly. A model-agnostic token budget or a normalized cost metric would make cross-paper claims easier to interpret.
Any word on code or artifacts?
They release code in the static reformulation of the second benchmark, which should help with replication and follow-on work.
All right, let's land the plane. What's the takeaway for our listeners?
Pairing a language model with a reasoning model, then teaching them a brief domain playbook from a tiny set of examples, gives you plans that honor both hard rules and everyday common sense while keeping costs down. It's a practical, portable recipe rather than a fragile prompt hack.
And it nudges the field toward learning reusable domain know-how, not just debating longer or calling the API more times. I like that.
Same here. That was LRPlan on AI Podcast. Thanks for listening.
Thanks, everyone. If you try it in the wild, let us know how it goes.